Radio Graphic Tube. X-rays are produced by energy conversion when fast moving electrons is suddenly decelerated in target anode. Main point: energy conversion, fast moving electrons, deceleration happens, and in target anode. Means what? Electrons are produced, they move fast from cathode to anode, hits the anode, deceleration of electron happens, and therefore X-rays are produced. Now cathode. Cathode is the negative end of the tube. Anode is the positive end of the tube. Let us draw the diagram. First we'll draw the glass envelope. Now anode, cathode, negative end, anode, positive end, filament, the spiral part of the cathode, electrons produced and then hits anode, and then X-ray is produced. Parts of tube: glass envelope, cathode, anode, and electric circuit. Let's first learn about glass envelope. Glass envelope is the housing in which we have cathode and anode. This glass envelope is made up of pyrites glass. Pyrites. Remember the word pyrites. In the glass envelope, we have inside vacuum. Now, why vacuum is present? Suppose if vacuum is not present and gas is present, then the electrons will interact with the gas molecules. Because of this interaction, there will be more production of electrons, and this electron production will be uncontrollable. Therefore, we have vacuum inside the glass envelope. Cathode is the negative end and anode is the positive end. Cathode, the negative end, consists of filament, focusing cup, and wire. Anode has two parts. Either it can be a stationary anode or it is a rotating anode. Now let us learn about cathode. Cathode is the negative end of the terminal. It consists of filament, focusing cup, and wire. Let's learn about filament. Filament is made up of tungsten. Why tungsten? First point, that it is the tungsten has a high melting point. What is the temperature? It is 3370 degrees Celsius. Second point, that it can be drawn into wires. Third point, why tungsten is used, that it has little tendency to vaporize. Therefore, it will have a long life expectancy. Electron production. Since electron is produced by filament, we learn the mechanism. First, current is passed through the filament. The filament will be get heated. Atom of the tungsten will absorb this thermal energy or the heat. There will be emission of electron. Since it absorbs heat and emission of electron, this is known as thermionic emission. These electrons, which is released from the filament, will form a small cloud in the vicinity of the filament. This is known as space charge. Now, these electrons in the vicinity forming a cloud will prevent other electrons from emission. This is known as space charge effect. Now we'll study about focusing cup. Second part of the cathode, filament, focusing cup. This focusing cup is made up of nickel. Filament tungsten, focusing cup nickel. Since electrons are negatively charged, they will repel each other. Therefore, the beam of the electron from the filament will be very wide because they are repelling each other. This is where role of focusing cup comes, where it will focus the electron beam so that it will have a narrow shape of beam. And since filament is getting heated, there will be vaporization of the filament and therefore deposition of tungsten on glass envelope. This will produce bronze color, which will indicate aging of the tube. Anode. It can be either stationary anode or rotating anode. Stationary anode is made of tungsten plus copper. Now why tungsten? High atomic number, which is 74, and high melting point 3370. Copper, why? Because it is a better conductor of heat than tungsten. Therefore it will increase the total thermal capacity of anode, and the melting point of copper is 1070 degrees Celsius. Remember, 3370 for tungsten and 1070 for copper. Rotating anode. Rotating anode is made up of tungsten plus rhenium. Now why rhenium? Because it will decrease the roughening of focal area, therefore it will increase the X-ray output and therefore increase thermal capacity. The speed of rotation is 3000 to 3600 rpm. Now let us draw the parts of a rotating anode. The glass envelope, outside which there is stator, inside is the rotor, the stem, and then the tungsten plus rhenium disc. This is the part of anode, and on the other end, cathode. The mechanism of rotating anode. Since there is vacuum inside the glass envelope, we have to discuss the mechanism of rotating anode. The mechanism is as follows. Current will pass through the stator, which is outside. It will produce magnetic field. This magnetic field will help in production of current inside the rotor, and because of which rotation will happen. Stem of rotating anode. It is made up of molybdenum. Now why molybdenum? Because it has high melting point. What is the temperature? 2600 degrees Celsius. Remember, 3370 tungsten, 1080 copper, and 2600 degrees Celsius for molybdenum. It is also a poor conductor of heat. Stem, the length is more important. Why? Because if the length is more inertia, more load. If the length is small, then heat absorption, therefore heat absorption decrease, therefore problem. The lubricant used inside the glass envelope is metallic silver, most commonly used. Oil and graphite were earlier used but not used nowadays.